In the frozen vacuum of space, over 13 billion light-years from Earth, something impossible is waiting for us. The James Webb Space Telescope has opened its golden mirrors and looked deeper into the abyss than any eye before it. And what it uncovered defies every law of physics we thought we understood. Galaxies that grew too fast, black holes older than the stars themselves, and signals from rogue worlds echoing across the cosmic void. If you love uncovering the universe's darkest secrets, stay with me, because what you're about to see will forever change how you view reality. Prepare yourself. We begin. One of the first discoveries Webb confirmed was a nightmare astronomers have been whispering about for years: the expansion crisis of the universe. For decades, scientists thought they knew how fast the cosmos was stretching. The Hubble Space Telescope gave one answer, and our best cosmological models gave another. The two numbers didn't match perfectly, but it was close enough to brush aside. Then Webb looked deeper, and instead of fixing the puzzle, it shattered it. The universe, it turns out, seems to be expanding at two completely different speeds depending on how you measure it. Imagine blowing up a balloon, but the top half stretches twice as fast as the bottom. That should be impossible. Physics demands that expansion happens evenly everywhere. Yet Webb's precision revealed the contradiction isn't a glitch, it's real. When astronomers measured expansion using Cepheid variables, distant stars that act like cosmic mile markers, they got one number. But when they calculated it using the cosmic microwave background, the faint afterglow of the Big Bang, they got a very different one. And this isn't some tiny error. It's a gap so wide it shakes the foundations of cosmology. Webb studied over 1,000 Cepheid stars across 5 separate galaxies, stretching 130 million light-years into space, and the contradiction didn't go away. Scientists call this the Hubble tension, but that phrase makes it sound tame, like an academic argument. In reality, it's terrifying. If both methods are right, then either our models of the universe are fundamentally broken, or some unknown force is tearing space-time apart in ways we don't yet understand. Maybe dark energy isn't acting the same everywhere. Maybe parts of the universe are stretching faster than others, creating cosmic rifts that violate the rules of physics. Nobel laureate Adam Rees, who led much of this research, admitted that if errors are ruled out, then we've misunderstood the universe itself. And if that's true, then our calculations of the cosmos's age, its size, and even its fate may all be wrong. But that was only the beginning. Webb then turned its gaze near the Big Dipper and stumbled on something so bizarre, astronomers gave them the nickname universe breakers. Instead of small, faint baby galaxies, Webb saw 6 massive star cities, mature galaxies filled with billions of stars that shouldn't exist so soon after the Big Bang. The universe at that time was only 3% of its current age. Yet here were galaxies as heavy and complex as our own Milky Way. It's like planting an acorn and finding a towering oak tree just 3 months later. These galaxies somehow grew 10 to 100 billion stars in record time. To achieve that, they would have had to churn out hundreds of new stars every year for hundreds of millions of years. Our Milky Way, by comparison, forms maybe 2 stars per year. The discovery doesn't just break our models, it obliterates them. Eric and Nelson, who first spotted these glowing red giants, described them as so bright and so old-looking that they shouldn't exist. Yet Webb captured them clearly. Astronomer Joel Lahar said it best: "We looked into the very early universe for the first time, and what we found creates genuine problems for science. Something is very wrong with our picture of cosmic history. The expansion of the universe is broken, and now the timeline of galaxy formation is collapsing too." And these were only Webb's first discoveries. Just when astronomers were still reeling from impossible galaxies, Webb uncovered something even stranger: a black hole that seemed to be wandering through space all on its own. Black holes are supposed to sit at the hearts of galaxies, surrounded by billions of stars, like anchors holding everything together. But Webb spotted one with virtually no galaxy at all. Alone, drifting, a cosmic monster in the darkness. This rogue black hole, known as QSO, carries the mass of 50 million suns crushed into a region smaller than our solar system. To imagine that, picture Earth as the size of a marble. Even then, this black hole would remain invisible, while containing more matter than hundreds of billions of stars combined. That alone is enough to send shivers down your spine. But what makes it even more terrifying is its timing. QSO exists just 600 million years after the Big Bang. And that's a problem. According to every theory we have, it should have taken far longer for a black hole of this size to form. Normally, you'd need the first generation of massive stars to live, die, and explode as supernovas before black holes could even appear. That process should take hundreds of millions of years. Yet here was QSO, sitting in the cosmic darkness long before stars had the chance to die. Scientists offered a few unsettling explanations. Maybe this black hole formed directly from the collapse of a massive gas cloud, skipping the star stage entirely. Or maybe intermediate black holes in the early universe fed so quickly that they grew at impossible speeds. But the most chilling idea is that QSO might be a primordial black hole, created in the first seconds after the Big Bang. If true, it would mean this black hole has been lurking in the dark since the very birth of the universe, waiting for billions of years until galaxies and stars finally lit up the sky. And Webb has found more of them. Hundreds of tiny glowing red dots in the early cosmos might be similar monsters, black holes that defy explanation, scattered throughout the young universe. If primordial black holes are real, it would mean the cosmos was seeded with these ancient giants from the very beginning, and some might still be wandering invisibly through our own galaxy today. But Webb wasn't finished. It soon uncovered a cosmic collision unlike anything we've ever seen. Astronomers call it the Infinity Galaxy, because its glowing shape resembles the symbol for infinity. Two massive disk galaxies slammed into each other head-on. But instead of merging into chaos, something impossible happened. Their central black holes didn't spiral together. Instead, Webb found a massive black hole floating directly between the two galactic cores, suspended in a river of glowing hydrogen gas. This is not supposed to happen. Black holes should either merge or one should get kicked away. Yet here, it appeared a brand new supermassive black hole was forming in the middle of the crash, not from the death of a star, but from the direct collapse of gas itself. Imagine a cosmic avalanche so powerful that it simply skipped every step and turned straight into a black hole. This discovery may finally explain why Webb keeps finding impossibly huge black holes so early in cosmic history. If gas can collapse directly into a black hole, bypassing stars, then these monsters can grow much faster than anyone thought possible. The Infinity Galaxy is like a laboratory frozen in time, showing us a process that breaks the rules of stellar evolution. And as the galaxies continue colliding, the central black hole is actively feeding, growing larger with every moment we watch. But galaxies aren't the only places where Webb found chaos. When it turned its eyes toward the Orion Nebula, Webb discovered something so bizarre it seemed almost playful. Hundreds of rogue planets, worlds the size of Jupiter, were drifting freely through space without stars of their own. Even stranger, many of them were paired, orbiting each other like lonely couples dancing in the dark. Astronomers call them Jupiter-mass binary objects, or jumbos. According to everything we know about planet formation, these systems should be nearly impossible. Planets are supposed to grow inside disks of gas and dust around stars. The idea that two giant planets could form and then stay bound together without a sun to stabilize them is almost unthinkable. Yet Webb found over 500 of these cosmic orphans. And the mystery deepened when scientists tuned radio telescopes toward them. To their shock, some of these rogue pairs were broadcasting powerful radio signals, bursts at frequencies that don't match anything we've ever seen from planets before. Not the usual interactions of magnetic fields, not the low hum of space weather, but intense, high-pitched bursts thousands of times higher than FM radio. Signals like this usually come from pulsars or quasars, not wandering planets. It appears the paired planets are acting like massive electrical generators. As they orbit each other, their immense gravitational and magnetic fields create powerful currents, producing strange electromagnetic signatures. Each pair seems to have its own unique personality. Some broadcast steady streams, others fire off random bursts. It's unlike anything in our solar system, and it raises an unsettling question. If rogue planets can generate such powerful signals, what else might they be capable of? For astronomers, the discovery of so many wandering pairs is deeply troubling. If there are hundreds in just one nebula, there could be millions across the galaxy. Entire graveyards of failed star systems, where planets were ejected and left to drift forever in the dark. They are cosmic orphans, cut off from the warmth of any sun, living only by the faint glow of their decaying cores and the strange dance of their magnetic storms. The early universe, it seems, was not the orderly place we once imagined. It was a violent, chaotic arena filled with impossible black holes, colliding galaxies, and planets cast adrift in the void. And Webb was only just beginning to show us how strange it really was. The deeper Webb stayed into the early universe, the stranger it became. At first, astronomers thought they would be studying the slow, steady growth of galaxies, watching simple stars form, live, and die in predictable cycles. Instead, Webb revealed a cosmos already bursting with complexity. Young star systems weren't following the rules. They were producing heavy elements like carbon, oxygen, and nitrogen, ingredients for life, far earlier than they should have. Normally, the universe's first stars, called population 3 stars, would have been made almost entirely of hydrogen and helium. Only after they exploded as supernovas would heavier elements begin to appear, seeding the cosmos for the next generation of stars and planets. That process should have taken billions of years. But Webb found young galaxies, barely a few 100 million years old, that were already rich in these essential elements. It's as if the universe had skipped ahead in its own script, jumping straight to complex chemistry before the curtain had even risen. One galaxy, James Webb 13-1, existed only 330 million years after the Big Bang, yet its light revealed traces of heavy elements it shouldn't have. The only explanation is that the first stars were far more massive and short-lived than we imagined, burning out in violent hypernovas that scattered elements across space almost instantly. Or perhaps something even stranger was happening, some unknown process creating the building blocks of life before stars had the chance. But Webb's surprises weren't limited to chemistry. When astronomers mapped the rotations of galaxies across vast stretches of space, they found something that should have been impossible. Galaxies separated by millions of light years, too far apart to influence each other, were spinning in the same direction, as if choreographed in some grand cosmic dance. Imagine standing on a continent and discovering that every windmill across deserts and mountains was turning in perfect unison, without a shared wind to move them. The simplest explanation, the universe itself might have been born spinning. If the Big Bang had angular momentum, if it wasn't perfectly uniform, it could have imprinted a preferred direction of rotation on everything that formed afterward. Some scientists even suggest this could be evidence that our entire universe exists inside a black hole, inheriting its parent spin at birth. A terrifying thought, that we're living inside a cosmic prison, cut off from a larger reality, and every galaxy's synchronized rotation is proof of that hidden origin. And yet, the mysteries continued. Webb discovered a black hole in the early universe that seemed to be eating matter 40 times faster than the laws of physics should allow. Normally, black holes have a speed limit, called the Eddington limit. If they try to consume too much too quickly, the radiation they produce pushes matter away, slowing down their feast. But this monster, known as LID 568, ignored the rules. It was devouring matter at impossible rates, growing larger and heavier with terrifying speed. To put it in human terms, it's like trying to drink from a fire hose. At some point, the pressure becomes too great, and you choke. But this black hole wasn't choking. It was drinking from 40 fire hoses at once. At such a rate, it could have gained most of its current mass in a single feeding frenzy, rather than over billions of years. Astronomers don't yet understand how this is possible. Maybe the matter falling in had strange properties, allowing it to resist being blown away. Or maybe black holes have ways of stabilizing their feeding we don't yet comprehend. Either way, LID 568 proved that the early universe was a place where even black holes broke their own rules. And just when astronomers thought they'd seen the peak of strangeness, Webb revealed something hauntingly beautiful: the Sleeping Beauty galaxies. These are massive galaxies, as large as our Milky Way, that existed only a billion years after the Big Bang. They had everything they needed: gas, dust, and dark matter to be blazing with newborn stars. But instead, they were silent. Their star-making engines had already shut down. It's as if someone had pressed pause on entire galaxies during the very moment they should have been most alive. Normally, galaxies at that stage of the universe's life cycle should be overflowing with new stars, devouring cosmic gas like fuel for fire. Instead, Webb found them dormant, vast cities of light where construction had suddenly stopped. Why? Some scientists think their central black holes may have heated the surrounding gas to such extreme temperatures that star formation couldn't continue. Others suspect they simply burned through their fuel too quickly, consuming everything in a brief but furious burst. But the most unsettling idea is that they shut down because of processes we've never seen before, mechanisms unique to the early universe that no longer exist today. Whatever the reason, the Sleeping Beauty galaxies are a reminder that the early cosmos was not just chaotic, it was unpredictable. Some galaxies grew impossibly fast, while others fell into silence long before their time. Together, these discoveries paint a picture of a universe that doesn't just bend the rules, it rewrites them completely. And Webb wasn't finished, because beyond the galaxies and black holes, beyond the strange chemistry and synchronized spins, the telescope would soon reveal something even more disturbing: evidence that space-time itself may not be as stable as we once believed. If everything so far seemed bizarre, Webb saved some of its strangest revelations for last. One of the most haunting discoveries came not from the distant universe, but from our cosmic backyard, Alpha Centauri, our closest neighboring star system. Webb detected what looked like a Neptune-sized planet orbiting Alpha Centauri A, sitting right in the star's habitable zone. The implications were enormous, a nearby world with the potential for life. But when astronomers returned to study it again, the planet was gone. No signal, no trace, nothing. Some theories suggest it has an extreme orbit, spending most of its time far from the star, only swinging close enough occasionally for Webb to spot it. Others think it might be shrouded in a cloud of dust, hiding it from view. But there's also a darker possibility. Maybe what Webb saw wasn't a planet at all, but something entirely new, some unknown cosmic phenomenon masquerading as a world. Whatever the answer, the vanishing planet remains one of the most baffling mysteries of our nearest stars. Yet while individual planets were playing hide-and-seek, Entire galaxies were being torn apart by something even more terrifying: dark matter. Webb's infrared vision revealed that galaxies caught in the grip of massive clusters weren't just colliding with each other. They were being shredded by invisible forces. Enormous streams of stars stretched across millions of light years, like cosmic scars carved by unseen hands. Dark matter, long thought of as just the scaffolding that holds galaxies together, suddenly looked much more violent. These hidden interactions don't emit light or heat. They leave no trace except destruction. Galaxies ripped open, their stars scattered across intergalactic space, their structures erased by forces we can't see and can barely measure. It suggests dark matter is not a passive background actor, but an active participant in cosmic violence, reshaping the universe in silence. And then, there are the cracks in reality itself. Webb has found hints of cosmic strings, hypothetical scars left over from the universe's birth. These one-dimensional defects in space-time would be like tears in the fabric of reality, stretching across the cosmos. Their gravitational effects could bend light in strange, impossible ways, producing lensing patterns that don't match any known distribution of matter. If confirmed, it would mean the universe carries permanent scars from its violent beginning, literal fractures in reality. At the same time, astronomers studying Webb's data have seen unexplained bursts of energy, strange radiation signatures, and anomalies around black holes that suggest space-time itself might not be as smooth or stable as we once believed. It may bubble and twist, quantum foam bleeding into the macroscopic world. The very fabric of reality might be weaker than we think. But if galaxies and space-time itself can break the rules, so can stars. Webb has revealed the universe is full of stellar cannibalism, stars devouring their companions and feeding frenzies so violent they can outshine entire galaxies. Binary star systems can end in catastrophe, with one star stripping material from the other until it collapses or explodes. Sometimes these events end in type Ia supernovas, sometimes in even more violent kilonovas that forge gold, platinum, and other heavy elements. These aren't rare events. They may be one of the primary ways the universe creates the ingredients for life itself. The stars, it turns out, are not gentle creators, but ravenous predators. And all of this leads to perhaps the most unsettling idea of all, that our entire observable universe may be trapped inside a black hole. The evidence is mounting. Galaxies across the sky appear to rotate in the same directions, as if imprinted with momentum from something larger. The expansion of the universe doesn't make sense, faster in some places than others. Primordial black holes existed before stars, as if seeded into reality from the very start. The black hole cosmology theory suggests that what we call the Big Bang was actually the moment our universe crossed the event horizon of an enormous black hole in a parent universe. From our perspective, it looked like sudden expansion. From the outside, it was simply collapse. And as we continue to fall inward, time itself stretches, giving us the illusion of an accelerating cosmos. If true, then everything we know, all the galaxies, all the stars, all the life that could ever exist, is trapped inside a cosmic prison. Every signal we send, every discovery we make, will remain locked forever behind an event horizon we cannot cross. And just as black holes within our universe might contain their own baby universes, we ourselves may be just one bubble in an endless multiverse of black holes within black holes. Webb has shown us a cosmos that is violent, unpredictable, and profoundly alien. The galaxies form too fast. The black holes eat too quickly. Space-time itself may be unstable, and reality might be nested inside something even larger. The universe is stranger and more terrifying than we ever dared imagine. As Webb turned from galaxies to planets, the discoveries became no less unsettling. For decades, scientists assumed they understood how worlds were born, dust and gas swirling around young stars, slowly building planets layer by layer. But Webb's instruments told a very different story. In the star-forming region NGC 6357, astronomers found a disk around a young star where Earth-like planets should have been forming. By every model, that disk should have been rich in water, ice-coating dust grains, feeding the birth of rocky worlds. Instead, Webb revealed something shocking. The disk was dominated not by water, but by carbon dioxide. Water was barely detectable at all. This means planets in that system will form with completely different chemistries than Earth. Instead of oceans, they may be born dry and hostile, sculpted by carbon compounds rather than water ice. Two theories try to explain it. Ultraviolet radiation may have blasted the water molecules apart, or unusual dust conditions may have favored carbon dioxide. Either way, it changes everything. If worlds can form like this, the galaxy may be filled with planets utterly alien to what we imagine, barren, carbon-choked, and lifeless. But the strangest worlds are the ones that already exist. Take 55 Cancri E, a so-called hell planet orbiting its star so closely it completes a year in just 18 Earth hours. Its day side is hot enough to melt copper, glowing like molten metal, while its night side is locked in frozen darkness. By all logic, a world like this should have lost its atmosphere billions of years ago. Yet Webb detected one, thick, dynamic, and impossible. The planet's atmosphere seems rich in carbon monoxide and carbon dioxide, swirling in brutal winds thousands of miles per hour. These winds carry vaporized rock from the day side to the night side, where it condenses and rains down as molten minerals. Picture storms where it rains liquid stone and metal, a cycle endlessly fed by volcanic outgassing from the planet's tortured interior. Its atmosphere is constantly destroyed by stellar radiation and constantly replenished by gases boiling up from within. 55 Cancri E is a world in permanent torment, its very crust cooking under its star's relentless heat. And then there are the Wanderers, one rogue planet, catalogued as SIMP J0136+0933, drifts freely through space without a star of its own. Alone in the dark, it somehow maintains one of the most complex atmospheres ever discovered. Webb revealed stacked cloud layers, iron vapor below, magnesium silicate above. When the weather shifts, the planet experiences storms where molten iron condenses and falls as metallic rain. But that's not all. Above its cloud layers, Webb detected hotspots powered by radio auroras, electromagnetic storms similar to Earth's northern lights but magnitude stronger. This suggests the planet has an unimaginably powerful magnetic field, strong enough to tear charged particles from interstellar space and ignite them into deadly light shows. Think about that. A starless planet, wandering through the void, hosting violent storms of iron and magnesium, lit by auroras more powerful than anything in the solar system. If worlds like this are possible, then the universe is stranger and far less hospitable than we dared to dream. And yet, Webb was just beginning to reveal the true chaos written across the galaxies. Because beyond these hostile planets lay entire cosmic structures behaving in ways no model could explain. As Webb widened its gaze back to the vast scales of galaxies, the universe began to look even stranger. In one corner of the deep sky, astronomers found a creature staring back, a galaxy that looked uncannily like a cosmic owl. At first, the resemblance seemed playful. Two glowing eyes of starlight surrounded by dust, its wings stretched wide. But this was no gentle owl drifting through space. It was a jellyfish galaxy, streaming long tentacles of gas and stars hundreds of thousands of light years into the void. Webb revealed those tentacles were not decorative, they were scars. The galaxy was being stripped apart by a cosmic headwind as it plowed through the dense gas of a galaxy cluster. Stars and gas were torn from its body, flung into intergalactic space, leaving behind trails of stellar refugees glowing with newborn stars. This process, called ram pressure stripping, is violent beyond comprehension. It shows us that galaxies are not serene island universes. They are prey, shredded as they move through the dense, turbulent webs of the cosmos. The owl's haunting face is really a mask of destruction, proof that galaxies can be both creators of stars and victims of cosmic violence. But Webb's next discovery was even more perplexing. Across the early universe, it detected 300 tiny crimson pinpricks scattered through its deep field images. Astronomers call them the little red dots. Each one shines with a brightness that doesn't match any known category of object. Some seem compact, like quasars powered by black holes. Others appear extended, like galaxies. But all are far brighter and more energetic than they should be at less than 1 billion years after the Big Bang. No one knows what they are. They could be galaxies forming at impossible speeds. They could be primordial black holes blazing with light as they consume matter. Or they might be an entirely new class of object, something that no longer exists in today's Karma universe. Their random distribution hints at something fundamental, as though the early cosmos had its own secret phase of evolution, one we never expected to see. And then, from even closer to home, came a discovery that shook astronomers on a more personal scale. Webb spotted Comet 3I Atlas, a visitor from another star system, streaking through our solar system. At first glance it looked ordinary, a 7-mile-wide chunk of rock and ice trailing a glowing coma of gas. But Webb's instruments revealed its true identity. It was 7 billion years old. That makes it older than Earth, older than the Sun, older than every planet in our solar system. This comet formed around a star that died billions of years ago. When that system was destroyed, perhaps in a violent supernova, it was ejected into interstellar space, where it wandered the galaxy for eons before passing through our neighborhood. Webb showed that its composition is unusual too, dominated by carbon dioxide rather than the water ice we expect from comets born in our solar system. It carries chemical fingerprints of a different age, a different star, a different world entirely. In a way, it's a time capsule, evidence of cosmic history from long before our own planet existed. Seeing it now is like meeting an ancient traveler, one that's been drifting alone for billions of years, older than everything we call home. And if one such object has arrived, there may be countless others, messengers from the deep past, slipping silently through the void, unnoticed until chance brings them near our sun. The cosmic owl, the little red dots, and the ancient comet all point to the same unsettling truth. The universe is not only stranger than we think, it is older, more violent, and far less stable than we ever dared to believe. And yet, even these revelations weren't the end. Because in the very heart of our own galaxy, Webb would uncover something even more disturbing. A black hole that pulses with the beat of a cosmic heart, hinting that space-time itself may be unraveling. Deep in the center of our own galaxy, 26,000 light-years away, sits Sagittarius A asterisk, a supermassive black hole 4 million times the mass of the Sun. For decades, it was thought to be quiet, a cosmic giant barely feeding. But Webb's continuous monitoring changed that image forever. Instead of silence, Sagittarius A asterisk was pulsing. Its accretion disk flickered and flared, sometimes glowing with bursts of radiation before fading again. These weren't regular beats like a ticking clock. They were chaotic, unpredictable, a heartbeat without rhythm. For 48 hours of observation, Webb watched as the monster throbbed with light, its event horizon surrounded by turbulence no theory could fully explain. Some flares were small, like lightning flashes inside the disk of gas. Others were massive, triggered when entire clumps of matter skimmed across the black hole's photon sphere, the region where even light is trapped in orbit. Each eruption reminded astronomers that our galaxy's heart is not still. It's alive, violent, and constantly reshaping the space around it. But the strangest revelation came not from a single black hole, but from the vast network of the universe itself. Webb surveys of the cosmic web, the filaments of gas and dark matter that connect galaxies, revealed something astonishing. Those filaments are threaded with magnetic fields, not simple or random, but organized into patterns eerily similar to the neural networks in the human brain. Think about that. Across hundreds of millions of light-years, magnetic fields are arranged in nodes and connections, branching structures that mirror the way neurons fire and link in our minds. These fields aren't just passive. They shape how gas collapses, how stars ignite, even how galaxies grow. It's as if the universe itself developed an early blueprint of complexity, weaving invisible networks long before planets or life existed. If magnetism was this intricate so early in cosmic history, then our models are incomplete. The universe wasn't a simple place that gradually built order. It may have been born with complexity encoded into its very fabric. And that fabric, Webb suggests, may not be stable. Across its deep surveys, Webb has found hints of cracks in space-time itself, gravitational lensing effects that don't match predictions, strange bursts of energy near black holes, patterns that could be signatures of cosmic strings, tears in reality left over from the Big Bang. Even more disturbing are signs of vacuum decay, regions where the quantum vacuum itself may have shifted to a lower energy state, releasing bursts of energy that ripple through space. If true, it would mean reality is not fixed, but fragile, capable of changing in catastrophic ways we don't yet understand. Together, these discoveries paint a chilling picture. Our galaxy's black hole beats with unpredictable violence. The cosmic web mirrors the structure of thought itself, and the universe's fabric shows signs of strain, as if reality is held together by threads thinner than we ever imagined. If the cosmos can crack, if space-time itself can unravel, then everything we know rests on a foundation more fragile than glass. And Webb is showing us those fractures, one by one. We've traveled across the cosmos, uncovering galaxies that defy time, planets where it rains molten rock, and black holes that pulse like beating hearts. Webb's discoveries reveal a universe stranger, more violent, and more fragile than we ever imagined. The deeper we look, the less certain reality itself becomes, and that is both terrifying and awe-inspiring. If you want more tips like this, make sure you hit the subscribe button, because every new revelation brings us closer to rewriting everything we thought we knew about existence. Until next time, keep wondering, keep questioning, and keep looking up.